Page 4 of correlation and regression. Anybody tired of graphing? We did a lot of graphing from page 1 to 3. Finally, we're going to take a break from graphing. We are going to use the calculator more heavily to figure out what the correlation line or the regression line would be, the best fit line. We're not going to eyeball it anymore. We're going to use the calculator's computing power to calculate exactly the equation of the line. So, before we start that, we're going to talk about Pearson's product moment correlation coefficient. Okay, and Pearson, who we know from other things we've already studied, like chi-squared. He also created something called the correlation coefficient, which is the letter R, the variable R. And R ranges between 0 and 1, and it's kind of a rating, which says if it's 1, very good correlation or perfect correlation. So if you have like 2 points and you have a line going exactly through those 2 points, that is perfectly correlated. Okay, those 2 points are correlated to the line. If you have a cloud of points, the line goes through the points, like some of our previous problems, like this one here. Okay, like this one here. The line is going through the cloud of points, but the points are not exactly on the line. That's usually what happens in your science projects and things, because in the real world, usually it doesn't happen that the points are exactly on the line. Okay, so in that case, we would say that it's like moderately correlated, and your Pearson's product moment correlation coefficient is probably going to come out to be something like 0.5, between 0.5 and 0.75, and that would be like a moderate correlation. Okay, and it gets worse and worse until you finally get to 0 correlation, in which case it's not a line at all. All right, and then there is also the negative case. Pearson's correlation coefficient can come out to be a -1, which would be a perfect correlation also, but it would be one of those cases where you had negative gradient, or the line goes down as you go from left to right, and we'll see what that looks like in a second. Okay. So just to review here, from 0 to 25, 0.2 to 0.25, we would call that very weak. And this is actually something you have to memorize for the exam. Okay, from 0 to 0.25, we consider that very weak. 0.25 to 0.5, we consider that weak. For 0.5 to 0.75, we consider that moderate. And from 0.75 to 1, we consider that strong. And strong is easy to remember. Very weak is easy to remember. Sometimes hard to remember if it's very weak or moderate. So sit down and figure out the best way for you to remember that, because you need to know that for exams. So remember, if R is -1 or negative, then we say there is a negative correlation, just like we talked about before. Before we eyeballed it to know if it was a negative correlation. This time we are going to use how negative R is. What exactly is the value for R? Okay, and the R is always going to be between -1 and 1. And the calculator is going to give it to us as part of the StatCalc package. So the first thing we're going to have to do is we're going to have to put the data in the calculator, and once we do that, the rest is easy. Okay? To set up your calculator, you do need to make sure that there is a certain flag on. And that you can find with second catalog. When you go into second catalog, there is a command which says something like diagnostics on, under D, of course. And if you want to speed down to D, what you do is you do alpha D, and then it'll go to the D's, but we're already there. So diagnostic on, that's what we want, diagnostic on. And once you do diagnostic on, whenever you do linreg, hey, you remember linreg from when we found equations that go through 2 different points? Well, now we're going to find lines that go through a cloud of points. So we're going to use linreg again. Make sure you use diagnostic on, though, because we want to know the value of R when we do it. Okay, so we did diagnostic on. Whenever your calculator gets like a factory reset or gets set up for the test, the exam, it's going to have diagnostic off. So you're going to have to go in there and turn it on. You need to know how to do that. Okay, so now we're going to go to stat edit, and we're going to put in this data here. And we only have L1 through L6, so I'm going to go back and I'm going to overwrite the data for L1 and L2. So I'm going to clear out this data. and I'm going to clear out the data for L2. And then I'm going to put in the data 22, 23, 22, 22, 23, 22, and then I'm also going to put in the Y data, which would be 59, 61, 65. 59, 61, 65. And math studies are pretty nice about it. They don't usually give you the Y data first. Usually the X data is first, the Y data is second, so don't reverse the order. I'm not going to make you watch me put in all this data now. You do it on your own. I'll do it on my own. We'll meet back up here in 2 seconds. Okay, so I finally got my data all in. You can see the last point is 20,38, 20,38. And then I'm going to find the correlation coefficient. This is a temperature and the number of ice creams sold. So like when it's a hotter day, maybe you're going to sell more ice creams than on a cooler day. Okay? Measured on 21 different days, so it's 21 different points. So find the correlation coefficient and comment on this value. So we're going to find the R. How do we find the R? We're going to do a stat, calc, lin reg, which you're very familiar with from last unit. And we're, instead of L5, L6, of course, we're going to put L1, L2, which is what we just used. And then we go down and we calculate it. And just like before, we're going to get the lin reg value, or the lin reg values of A and B. So the gradient is 4.9 and the y-intercept is negative 53. But they also give us the R squared and the R values, which are related to the Pearson's coefficient. R squared is the Pearson coefficient squared, and the correlation coefficient R is 0.931, for example. Okay, so let's write that down. So the R value is 0.931, and remember that if you have a Pearson's correlation coefficient of 0.931, the correlation is strong. So we'll say that the correlation is positive strong, because we know it's positive because it's a positive 0.931, and we know it's strong because it's 0.931 is between 0.75 and 1. So if it was negative 0.931, then we would say it is negative strong. Okay? And the rest of these problems here are all the same types of problems. They give you an X, they give you a Y, you put it in the calculator, you figure out what the correlation coefficient R is, and then you comment on if the R value is positive or negative, and if it's strong, moderate, weak, or very weak. Okay, and that's the way all of these work. You just put it in the calculator, you interpret the R value, and as you can see, I mean, these are like test questions, so the test is going to ask you to interpret, is 0 to 0.25, is that very weak? Yes, and so you need to memorize those, unfortunately. Okay, so that's number 4. That's page 4, and if you got it after 2 or 3 problems, okay, but make sure you really know how to use the calculator, and make sure that you know how to turn diagnostics on after the calculator is reset, because when you do the exam, the calculator will be reset before it's given to you. That's it for page 4.